Hi, I'm Tin. Welcome to Mathinics. In this video, we're gonna learn about data, table, and graphs because those are the such big topics. We'll only be able to cover a few key concepts in this video, but they should give you a good foundation to build on. Data, simply put, is information about the world. The type of the data we usually deal with in math is called quantitative data, because it involves quantities that we represent with numbers. Quantitative data comes in two basic types. Continuous data is data that can have any value and range. For continuous data, there's an infinite number of other possible data values in between any two actual data values. For example, if you ask an ice cream shop how much ice cream they sold on a hot Saturday afternoon, they might tell you 14 or 15 kilogram. But they could also tell you that it was any number in between, like 14.6 kilogram or even 14.625 kilogram, if they can measure that precisely. On the other hand, discrete data is data that only have specific values. With discrete data, there are not any other possible data values in between any two consecutive values. For example, if you ask an ice cream shop how many flavors they sell, they're going to respond with a whole number like 1, 2, 3, or even 31. They wouldn't give you any in-between number because they couldn't have a fractional amount like 31.4159 flavors.
Hi there, it's Jen. So continuous data typically comes from a process of measurement, and the values you get are only limited by the precision of the measurement device you're using. However, discrete data typically comes from the process of counting, which is often limited to specific values like whole numbers or integers. To see the difference, think about two types of data associated with a baseball player. The number of home runs that a player hits each season is an example of discrete data. It can be only a whole number, but if you keep track of the average distance a player hit the ball, that would be an example of continuous data because it could be any decimal value that you could measure. Now that you know a little bit about quantitative data, let's talk about ways data can be organized or formatted. Naturally, the more data that's collected, the more important it is to organize. It is so it doesn't become a chaotic jumble of numbers. Organizing data is typically done with a data table. Most data tables are made from the intersection of vertical columns and the horizontal rows.
Hi Mathinics, this is Melissa and this is data tables. Each box that formed by this intersection is called a cell and it can hold the number or other data in it. The columns and rows have tables to help you interpret the data and the cells. For example, this data table shows the result of a class survey about students' favorite foods. 5 columns that are each labeled with a choice from the survey like pizza or tacos. It has a single row that labeled a number of students. These labels make it easy to tell what the numbers and the cells mean. For instance, the 9 is at the intersection of the column for hamburgers and the row for number of students. So we know that 9 students answered hamburger in the survey. These tables happens to be in horizontal format because there are more columns than rows. But there's no reason couldn't switch the column and rows to get a vertical format instead. Of course, the more data a table holds, the more complicated it gets. For example, These data tables organizes a lot of quantitative data about the climate and the Yellowstone National Park. It's got a column for a month of the year and the several rows corresponding to weather measurements, like average high and low temperature and average precipitation and snowfall. A data table like this can be very useful because it can help answer questions like which month is typically the warmest in the Yellowstone. If you look at all the numbers and the rows about temperature, you'll see that the highest numbers are in the columns labeled July. But there's something that would be even more useful than data table for answering questions like that, and that something is called a graph.
Hi there, it's Lovely, and I will show you that something useful than a data table for answering questions, and that something is called a graph. Graphs are visual representations of data. Instead of using rows and columns of numbers, graphs use a variety of visual elements like points, lines, rectangles, or other graphics to make a picture of the data. To see how helpful graphs can be, let's focus on the row of data that records average rainfall and see a graph of the data only. This particular type of graph is called a bar graph or a bar chart because it uses rectangular bars to represent numeric values. Just like the data tables, the graph has levels onto its sides. These sides are called the axes of the graph. The horizontal axis on the bottom lists of month of the year, while the vertical axis on the left side is a sequence of numbers to show the rainfall in inches. As you might expect, the height of the bars in a bar graph correspond exactly with the numbers in the table. You can see that by looking at the scale on the vertical axis. The data tables tell us that the average rainfall for the month of May is 2 inches. And the height of the bar for that month on the graph exactly matches in the 2-inch mark on the vertical axis. You can almost imagine that rain cloud came along and filled up the bar to that level. Notice how easily the graph led us to see how the rainfall changes throughout the year. We can quickly find the highest and lowest month because our brains are able to compare the size of the bar much faster than they can compare the numbers in the table. By looking at the scale on the left side of the graph, you can see that the bar represents 14.5 inches of snow. Notice that these two different bar graphs have different number sequences or scales. In their vertical axis, the rainfall graph starts at minimum value of 0 inches and goes up to a maximum value of 2.5 inches. While the snowfall graphs start at 0 and goes up to max of 16. Also notice that each graph uses a different size subdivision on the vertical axis. The rainfall graph has a division every 0.5 inches, while the snowfall graph has a division every 2 inches. The size of these subdivisions is called the interval of the axis. This combination of a minimum value of maximum value and interval form the scale of an axis.
Hi, it's Grace. This combination of minimum value and maximum value and interval form the scale of an axis. When making a graph, it's very important to choose a scale that does a good job of displaying the data in a clear and understandable way. For example, if we use the same scale for the rainfall data as we did for the snowfall data, our graph would look like this. That's not good. Now, you can hardly tell the difference between the height of the bars because they're also squished down below the 2-inch mark. Likewise, if we use the scale of the rainfall graph for the snowfall data, a lot of the values will be off the chart. So keep that in mind if you ever need to draw a graph yourself. You want to pay close attention to the range of values in the dataset so that you can choose a minimum, maximum, and interval that are a good match for the data you need to graph. For example, what if you have a data table that contains negative values? Like this one that tracks how much money an investor. Monthly gain was $800, but there are some months with negative numbers like negative 400. Tama! Tama! Which means the investor lost money. Fortunately, bar graphs can be adapted to handling negative values too. All you need to do is extend the vertical axis scale. Tama! Using negative values that go below the horizontal axis, that way you can display negative values as bars that go down instead of up. Of course, bar graphs aren't the only way to turn data into a graph. There are actually many different kinds of graphs. Yes, some of which are better than others for certain types of data. Unfortunately, we don't have time to cover all these different graphs in this video. Instead, we'll just focus on one more very common option called a line graph. Line graphs are great for many types of data, especially data about how things change over time. Yes, the Yellowstone data table we saw previously also had data showing how the average high and low temperature. If we compare it to the bar graph we made for the precipitation data, you'll notice that the bar graph only had horizontal interval lines for tracking values on the vertical axis, while the line graph also has vertical interval lines for tracking values on the horizontal axis. These two sets of lines form a grid. That makes it easier to locate individual data points on the graph. For instance, notice that for the month of June, yes, yes, June, the dot exactly at the intersection of the vertical line for June and the horizontal line for 70 degrees. Perfectly with the data in the table which show an average temperature of 70 degrees in June, and if you don't count them all, you'll see that there's 12 dots total. One for each value in that row of the data table after all these dots were plotted on the graphs. They were connected with line segments between each adjustment pair. Why was this done?
Hello guys, Christine here. To help us identify any trends in the data, a trend is simply a pattern in the data like increasing, decreasing, or staying basically the same. Identifying this sort of trends in data can be helpful in a couple different ways. First, trends can help you understand data on a higher or more general level. For example, the trends in this Yellowstone data is that the temperature increases from January to July and then increases from August to December. The second trend can be sometimes help you make predictions about what might happen in the future. For example, if you have a line graph showing how the population of the bison herd was changing over time, it might help you predict how many bison you'd expect to see the next year. So,
Line graphs are great from displaying data in any ways. Another strength of line graphs is that they make it fairly easy to plot and compare multiple sets of data and then using different lines. Multi-line graphs like this will usually use different colors of line or line styles. Well, there's a bar graph and a line graph of that data side by side. Can you think of a reason why the line graph wouldn't be a good way to represent this data? Yup, this is because the options on the horizontal axis aren't related to any natural sequence. It doesn't really matter which order the different foods are listed in. And because the order isn't important. Any trend you might see by using a line graph doesn't have any real meaning. In fact, it could actually be misleading to use a line graph for a data like this because it also implies there could be choices in between and survey options like taco pizza or pizza hamburgers. So in case like this, it's better to just stick. That's why line graphs are often used for data like occurs over time. Time forms a natural sequence where trend lines make sense, and there are always possible values in between with whatever times intervals is used on the graph. Alright, so now you have a basic idea of how data and graphs work. You'd learn about continuous and discrete data and how it's organized using data tables. You'd also learn how data can be displayed on graphs to make it even easier to understand. As I said, there are many different types of graphs, but for now, just make sure that you understand how to interpret bar graphs and line graphs. The best way to do that is to look at a lot of different ways to those graphs and answer any available practice problems on your own. As always, thank you for watching Mathematics and see you all next time. Bye-bye!